Let's talk SOLIDWORKS Plastics. Now, SOLIDWORKS Plastics comes in 3 different flavors: standard, professional, and premium. The best way to think about it is by who's using it. In this video, we're going to show you how to use SOLIDWORKS Plastics Standard, which is meant for someone who designs parts that will be injection molded. So understanding how it fills. Plastics Professional is more for people doing mold work, so they need to understand filling and packing. And Plastics Premium, that's for people doing detailed analysis so they can understand warping and cooling. So let's dive in to SOLIDWORKS Plastics Standard. We'll get started with a new study. And you can choose the injection process. Here, we'll keep it simple with a single material, and we'll look at just a shell mesh. It's a way for us to get quick results for simple geometry. Now, let's work our way down the list of options in the Plastics Manager. Here's the type of simulation where we're going to focus on just the filling operation. This is where we include or exclude steps in the process. We can simplify the calculations to make sure we get whatever we want. Next is our settings for the process. Here we're defining the injection process specifically. Let's start with the material. The material library here is incredibly extensive. You can sort by company or family of plastics. For this, let's go with a generic polycarbonate. You hit the green check mark to accept, and now we'll just continue down the process. Let's define where this fills from. This is like a gate location, but it's a simplified version of that. It's essentially just where does the plastic enter the cavity. Now let's create our mesh. The meshing is incredibly fast and robust. This is where we're breaking it down into small pieces to solve those complex problems. This looks good just out of the gate, but we can even bump this up and make it a little bit more fine. This gives us a little bit more fidelity in our model to capture more of the curvature and small features. And just like that, we've meshed 2 times if you're keeping score at home. Now click the check mark to accept that, and we'll be ready to run our simulation. So now we're running the filling process. We'll fast forward through this, but pay attention to how the live preview shows up, letting you see the results as they're solved. All right, we're done. Now let's take a look at these results. We have some graphs and some numbers. We can start by animating this to get that lens to look into our mold. So now let's look at the most useful plot here, the ease of fill plot. This one answers the essential question of, is this gonna fill? Is there a short shot? Is there a geometric issue with my design that's gonna prevent this from being filled? Yes or no? We're looking for all green here. And it's telling us that based on our machine and process, our plastic geometry, it's not going to have a short shot, and we can make this. So let's look at some other plots here. Some things like air traps, weld lines. There's some graphs here that give us insight into some warpage predictors, so we can understand how this is going to perform. And there you have it. That's how you use SOLIDWORKS Plastics step by step. It's that simple. Let's switch gears here and now walk through a use case on how a designer might use SOLIDWORKS Plastics Standard to guide them in their design decisions. So for example, here we started with this pretty thick model on this smoke detector cover. Let's try to thin this out. I have a configuration set up here where we're going to change the thickness from 5 millimeters to just 1 millimeter wall thickness. This will fill a lot quicker and use a lot less material, saving us a lot of costs. So let's load in the results. I right click, see the summary, and I immediately am directed to the notification here that there's a short shot. It's surfacing this to me as the designer, letting me know that there's something to look out for. I have an issue. I'll read in the flow results, immediately go to the ease of fill plot, and I find out that, hey, it actually can't be filled. So I see exactly why that happens and where that happens. Looking at the fill time plot here, looks like I took it a little too far in thinning out the geometry. So let's take a step back, add some thickness back to that, read these results in, and again, immediately going to that ease of fill plot. It's green, telling me, awesome, this geometry can be filled. Now let's look at some other things. How about the pressure here? It's at 50 megapascals to fill this part. maybe I can make an adjustment here. Maybe I want to use a different machine. Maybe I want to use a different supplier, right? So now I can understand the impact that my choices have on this overall process as a designer, as a part designer, as a SOLIDWORKS user. So now let's change the injection location. See if this has any effect on it. I see it kind of didn't. So let's make a different choice. How about a different material? How about a blend? Let's see if that can reduce that number. So I'll read this blend in and look at the plot. Now let's go into the details here and see what's the pressure value. And we're able to cut that down significantly, making sure everything's green. Of course, I always want to know if this can be filled. So that's how SOLIDWORKS Plastics can be used to help guide you to better understand the implications that your design decisions have on the injection molding process. And that's just the start. That's SOLIDWORKS Plastics Standard. So stay tuned for the next video where we take a deeper dive into the more advanced capabilities of SOLIDWORKS Plastics, professional and premium, where we look at things like mold design, runner balancing, as well as analysis from warping and cooling. Stay tuned.